Okay, welcome back. Chapter 3 begins with the periodic table. You will have a periodic table to use on the exam. Be familiar with the groups and periods, remembering that your groups are your columns that go up and down in the periodic table, and your periods are those that go across. Know the different classification of the groups within the periodic table, beginning with the left side. In the far left column you have your alkali metals, followed by your alkali earth metals. Then you have the block that's in the middle of the periodic table. These are called your transition elements. And then on the right side of the periodic table, the next to the last column are your halogens, and then ending with your noble gases. So do know the classification of the groups. Also be able to know the difference between the metals, nonmetals, and metalloids within the periodic table, and also know different properties of metals that nonmetals do not have, and then metalloids also react differently than nonmetals and metals. So do know the difference in their reactivities. The metals are on the left side of the periodic table. Your nonmetals are on the far right side of the periodic table. Your metalloids are on almost the far right side, and it's going to be like a jaggedy staircase that is leaning this way. There's multiple pictures in your book that do show that are color-coded, distinguishing the metals, nonmetals, and metalloids. Then, leading into the atom, know the list. I believe there's 4 or 5 different topics of Dalton's atomic theory. Also know what Rutherford's gold foil experiment is and what contributions it made to knowing what types of subatomic particles we have. Know the 3 types of subatomic particles, your protons, your neutrons, and your electrons. Knowing that your protons are positive, your neutrons are neutral, and your electrons are negative. Your protons and neutrons are within the nucleus in the center of the atom, and it's very dense and compact, and the electrons are moving around on the outside of that nucleus. And remember that when you have things react with each other, it's going to be the electrons that come in contact first, and we'll discuss more of that as we talk about types of bonding, ionic and covalent bonding a little bit later. Know your major difference between atomic number and your mass number. Your atomic number comes from your periodic table. So here's a block example of the periodic table. Listed here is going to be your symbol for your element. Some are 1 letter, others are 2 letters. It's always going to begin with a capital letter, so if it is 1 letter it will be indeed just 1 capital letter. If it's 2 letters, it'll be an uppercase letter first and then a lowercase letter second. Your atomic mass number, your atomic number is going to be the number that is on top, and then your atomic mass will be on bottom, and we'll talk more about atomic mass once we get into chapter 6. This will be a number based on the average of the naturally occurring isotopes, and do know the difference between the different isotopes. Know the general definition of an isotope. So going back to atomic number, your atomic number in the periodic table is again going to be this top number, and it's going to be equal to the number of protons within that element. Most of all of the elements in the periodic table as written are assumed to be neutral. So if it is neutral, indeed your number of protons is going to equal the number of electrons. Now, on the other hand, when you are discussing isotopes, a different type of notation is used, is a nuclear symbol. This will deal with your mass number. Your nuclear symbol is going to have the abbreviation of the element. I'm just using variables x and y in this example, and just x. This is going to have on the left side, on the top will have a number, and then also a number here. Again, don't get this confused with the periodic table notation. This is going to be what is called a nuclear symbol, and you will use the nuclear symbols when distinguishing the different isotopes. The top number is going to be your mass number, and the bottom number is going to be your atomic number. So in the periodic table, the atomic number is on the top, but in the nuclear symbol, your atomic number is on the bottom. The atomic number will still represent the number of protons. However, the mass number is going to represent the number of protons plus the number of neutrons. Your isotopes will contain the same number of protons and electrons. They will only differ by the number of neutrons. So go ahead and take a moment now and pause the video if you need to, and I will be back shortly, and you will have a new list of material covering the rest of Chapter 3.